Welcome to Python Asyncio, explained for beginners. Have you ever wondered how some Python programs can do multiple things at once without using multiple threads? Or how web servers can handle thousands of simultaneous connections efficiently? That's exactly what Asyncio does. In this tutorial, you'll learn everything you need to know about async programming in Python, from the basic concepts to practical examples. We'll cover async functions, the event loop, running tasks concurrently, and the most common mistakes beginners make. By the end of this video, you'll understand not just how to write async code, but why it works the way it does. Let's dive in. First, let's understand what problem Asyncio solves. Normal Python code runs line by line, which is fine for most things, but it becomes a real problem when your program has to wait, like when downloading files, calling APIs, or reading from a database. Look at this synchronous code on screen. We're downloading 3 files, each taking 3 seconds. Watch how each download waits for the previous one to finish completely. The first file downloads, finishes. Then the second starts, finishes, then the third. Total time, 9 seconds. This is because Python is blocked, sitting idle while waiting for each I/O operation. Now imagine if all 3 could download at the same time. That's where Asyncio comes in, and it's about to change everything. Before writing any async code, you need to understand 3 fundamental concepts. First, async day. This keyword tells Python that this function can pause and resume. It's called a coroutine. Second, await. This is how you pause a coroutine to wait for something, like a network request, without blocking the entire program. Other tasks can run while you're waiting. Third, the event loop. This is the engine running behind the scenes that keeps track of all your tasks and decides what runs next. You rarely interact with it directly. Asyncio handles it for you. Think of the event loop as a conductor orchestrating an orchestra, making sure each instrument plays at the right time. Master these 3 concepts, and you've mastered the foundation of async programming. Let's write your first async function. Look at the code on the left. We use async to create a coroutine called greet. Notice how it looks almost identical to a regular function, except for the async keyword. Inside, we print hello, then we await asyncio.sleep for 1 second. This is crucial. We use await asyncio.sleep, not time.sleep. The await keyword pauses this coroutine for 1 second, but unlike time.sleep, it doesn't freeze the entire program. Other tasks can run during this pause. Then we print goodbye. To run this, we use asyncio run, which is your program's entry point into the async world. It creates an event loop, runs your coroutine, and cleans up afterward. The key takeaway: always use await asyncio inside async functions. Never time.sleep. This small difference is what makes async magic possible. Now here's where async gets really powerful. Let's rewrite that download example using Asyncio. Watch the code carefully. We define an async download function just like before, but in main, look at what we do. We call asyncio create task for each download. This is the magic. Create task schedules a coroutine to run without waiting for it right away. All 3 tasks start immediately and run at the same time. Then we await each task to wait for them to complete. Watch the output on the right. All 3 downloads start together, and they finish in order of their duration. Photo first at 1 second, music at 2 seconds, video last at 3 seconds. Total time, approximately 3 seconds instead of 9. That's 3 times faster, just by running tasks concurrently. The key insight: create task is like putting something in the oven and walking away to do other things, rather than standing there watching it cook. There's an even cleaner way to run multiple coroutines at once using asyncio.gather. Look at this example where we're fetching weather for 3 cities. Instead of creating tasks manually, we pass all 3 coroutines directly to gather. Watch how all 3 start fetching at the same time. Gather waits for all of them to complete and returns a list of results in the same order you pass them in. This is perfect when you need to run several independent operations and collect all their results. The beauty of Gather is its simplicity. One function call handles everything. It starts all coroutines, waits for them all, and gives you back the results as a list. You can then iterate over that list to process each result. This pattern is so common in async Python that you'll find yourself using Gather constantly once you understand it. This distinction confuses a lot of beginners, so let's make it crystal clear. When you await a coroutine directly, it starts immediately, but you wait for it to finish before moving on to the next line. This is sequential execution, one thing at a time. When you use createTask, the coroutine also starts immediately, but you don't wait for it right away. You get a task object back, and the coroutine runs in the background. You can then start other tasks and await them all later. This is concurrent execution, multiple things at once. Think of it like cooking breakfast. If you await each item, you cook the eggs completely, then the toast, then the bacon. If you use createTask, you put everything on at once and check on each when it's done. The second approach is dramatically faster for independent tasks. Use await when tasks depend on each other. Use createTask when they don't. Errors in async code work just like regular Python exceptions, which is great news. You use try and accept exactly the same way. Look at this example where we have a risky task that might fail. We wrap our gather call in a try block. When one of the tasks raises a value error, it bubbles up through gather, and then we catch it in the except block. The important thing to know is that when one task in gather raises an exception, gather propagates that exception immediately. The other tasks might still be running in the background, but you won't get their results. This is usually what you want. If something fails, you handle the error right away. Just remember, async exceptions are still Python exceptions. All your existing error handling knowledge applies directly. Sometimes a task takes too long and you don't want to wait forever. That's where asyncio.gather comes in. Look at this example. We have a slow API call that takes 10 seconds, but we only want to wait 3. We wrap the coroutine in wait for and specify a timeout of 3 seconds. Watch the progress gauge fill up as time passes. At 3 seconds, the timeout triggers, and a timeout error is raised. We catch it in our except block and handle it gracefully. This is extremely common when working with real APIs and network requests, where you can't guarantee a response time. Without timeouts, a single slow server could hang your entire application. With wait for, you maintain control and can fail fast when things take too long. Always use timeouts for external dependencies. Let's cover the most common mistake beginners make: forgetting a wait. Look at the wrong example on the left. We call greet without a wait. This doesn't run the function at all. It just creates a coroutine object and does nothing with it. Python might even warn you that the coroutine was never awaited. The fix is simple. Add a wait in front of the call. Now the coroutine actually executes. This mistake is easy to make because the code looks correct. You're calling the function after all. But in async Python, calling an async function without a wait is like buying a ticket to a concert but never going. The show happens, but you're not there to experience it. Always remember, async functions need a wait to run. Mistake number 2, using time.sleep. Using time.sleep. This is a critical error that defeats the entire purpose of zarasync. Look at the wrong example. We use time.sleep for 2 seconds. This blocks the entire event loop. No other tasks can run during those 2 seconds. Your async code might as well be synchronous. The correct approach is to use await asyncio.sleep. This pauses only this task and lets the event loop run other tasks while waiting. The difference is enormous. Time.sleep to look and Navaras docs while waiting. The difference is enormous. Time.sleep and sleep and sleep is like one car stopping at a red light while other cars keep moving. Always use await asyncio.sleep. And sleep is that. Nudly is my diving which had come sold pro grav way sleep. Mistake number 3. Calling asyncio.gather inside an async function. This is wrong because asyncio.gather creates a new event loop, and you can only have one event loop running per thread. Look at the wrong example. We're already inside an async function, so there's already an event loop running. Calling asyncio.gather tries to start another one, which causes an error. The correct approach is to use await to call other async functions, or create tasks if you want to run something in the background. Remember, asyncio.gather is only for the top level of your program, where there's no existing event loop. It's your entry point, not a tool for calling async functions from within async code. Use await or create tasks instead. When should you use asyncio? The answer is simple. Use it when your program spends a lot of time waiting on things outside of Python. This includes calling web APIs, fetching pages from the internet, reading from or writing to a database, listening for network connections, and building real-time apps like chatbots or live dashboards. In all these cases, your program is waiting for I/O operations to complete, and asyncio lets you do other work during those waits. However, don't use asyncio to speed up heavy calculations like sorting huge lists or processing video frames. For CPU-intensive work, look into multiprocessing instead. Asyncio is for I/O-bound tasks, not CPU-bound tasks. Know the difference, and you'll choose the right tool for the job. Here's a quick reference to keep handy when writing async Python. First, use async.def to define a coroutine. Second, use await to pause and wait for a coroutine to complete. Third, use asyncio.run at the top level to start your async program. Fourth, use asyncio.gather to run multiple coroutines concurrently and collect all results. Fifth, use asyncio.coroutine last to hard to reverie for tani settles. You want division. And the sixth, use asyncio.wait for code as to add a timeout to any coroutine. These 6 patterns cover most of what you'll do in async Python. Keep this reference nearby, and you'll be writing efficient async code in no time. Remember, the key to async is understanding when to await and when to create tasks. Congratulations! You've mastered Python asyncio. You now understand the 3 key concepts: async.def for defining coroutines, await for pausing execution, and the event loop that manages everything. You know how to run tasks concurrently with create task and gather, how to handle errors and timeouts, and most importantly, you know the common mistakes to avoid. Asyncio takes a little getting used to, but once it clicks, you'll find yourself reaching for it anytime your Python program needs to talk to the outside world efficiently. If you found this tutorial helpful, please like and subscribe for more Python content. We have even more tutorials coming soon covering advanced async patterns, WebSockets, and async web frameworks. Happy async coding!